Okay, this video is for my Calculus 1 students, and we're still working on antiderivatives. I did a video with all the even problems that we did in class, and I ended at 22, so I'm going to start at 24 for this. Now, this one, they give us f prime of x equals 8x cubed plus 12x plus 3, and they tell me f of 1 is 6. Well, the only thing with this is a little deceptive is we've been using a small f of x for our first derivative and a capital F of x for original function. Here they actually showed the prime, and so this is our original function. So this could be the same as a capital F of 1. They kind of go back and forth in between, and it's kind of confusing sometimes. So I just wanted to show you. So this is our first derivative, and this is our original function. So we're going to do antiderivatives to go backwards, if you will, to find my original function. And since they gave us information, we can actually figure out what our C would be. So I'm going to do f of x. It's all set up. So these are all power functions. So I can actually go through and say, okay, I'm going to add 1, multiply by 1/4. So I get 2x to the 4th. Add 1, multiply by 1/2. And 3x plus c. And that's all we could do if they didn't tell us this information here. So now I'm going to actually plug in f of 1, and this will help us find what c would be. So 2 times 1 to the 4th plus 6 times 1 plus 3 times 1 plus c, and it equals 6. So I end up getting 2 plus 6 plus 3 plus c equals 6. So that's 11 plus c equals 6. So c is going to equal -5. So our f of x function is actually 2x to the 4th plus 6x squared. This should be 6x squared up here. Sorry, that's why I'm hesitating. This should be squared here. I'm sorry. And then 6x squared. It didn't change our answer, but I'm lucky. Plus 3x minus 5. So there is our original function because they gave us some information. All right. The next one we're looking is at 26. And when I look at 26, I see that it's not really set up very well to do this. So I'm going to rewrite this to f prime of x. I'm going to write it as 2x minus 3x to the -4. Again, they gave us information from our original function so that when I start doing my antiderivatives, I can use that information to find out what c is. So we're going to go backwards. I know f of x, add 1, multiply by 1/2, x squared, add 1, so it'd be -3, multiply by -1/3, so it turns positive x to the -3 plus c. And now I know that f of 1 is 3, so I'm actually going to plug that in. F of 1 is going to be 1 squared plus 1 to the -3 plus c equals 3. So I end up getting 1 plus 1 or 2 plus c equals 3. So c equals 1 as well. A lot of 1's in that one. So my original function ends up coming out to be f of x is going to be x squared, ready, plus, we can do 1 over x cubed if you will. I'll just rewrite it here, plus 1. Or you could have wrote it as x to the -3. That would be fine as well. So that's how we would do 26. I'm just erasing this because I kind of covered that. All right, let's go up to 28. So 28, I have a function. It looks like a quotient, so I have to do some work to it before I can actually do this. So I'm going to write it like, when I look at it, I said, okay, maybe I can bring this up to the -1/2, and then I go, wait a minute, this kind of looks like the inverse sine antiderivative. So when I go to do my f of x, it really comes out to be 4 inverse sine of x plus c. Now, I know a lot of people, when they do the trig functions, like, how would you know that? I said, well, you got to kind of look at it and say, how would that be? And you don't know how to do anything with a quotient yet. So I kind of look for things like that I know that it might possibly be. Now I'm actually going to find f of a half and put it equal to 1 so I can figure out what my c is. So f of 1/2 equals 4 inverse sine of 1/2 plus c, and it equals 1. And I do know, and this has to be in radians as well, that the inverse sine of a half, if you're thinking of degrees, is 30 degrees, but we're doing in radians, so that's going to be pi over 6. So I have 4 times pi over 6 plus c equals 1. Those two together come out to be 4 pi over 6 is 2 pi over 3, so let's kind of put that together. Plus c equals 1. So c is going to equal 1 minus 2 pi over 3, which I know is ugly, but that's what c is. And it's a constant, so if I took the derivative, it would be 0. So my actual function here actually turns to f of x is 4 inverse sine of x plus 1 minus 2 pi over 3. That is my actual original equation. All right, I'm going to do one more, I think, on here. I'm going to try to get 30 in here, and then I'm going to stop this. Now, 30 is pretty cool because they gave us a second derivative. So what we're going to do is go backwards to the first and go backwards to the original. And look what they gave us, information for our first derivative and for our original, so we can actually find exactly what it would be. So let's go backwards and find f prime of x. So this is all set up nice because they're power functions. Raise it 1, multiply it by 1/4, so that's 2x to the 4th plus 5x plus c. Now I'm going to go up here and use this. F prime of 1 is 8, so f prime of 1 is going to be 2 times 1 to the 4th plus 5 times 1 plus c equals 8. So I have 2 plus 5 plus c equals 8. So 7 plus c equals 8, so c is 1. So my actual f prime of x is 2x to the 4th plus 5x plus 1. So that's nice. So here's what I started with right here. We did the antiderivatives. They gave us this information. Now I know my first derivative is actually this. Now we're going to go backwards to our original function. So we're going to do antiderivatives again of all these power functions, which is kind of cool. So I have f of x is going to be add a power. That's going to be to the 5th multiplied by 1/5. So I have 2/5 x to the 5th, okay, plus add a power, that's 2, divide by 2, or multiply by 1/2. 5/2 x squared plus 1x, or x, plus c. So there's my original function. Now I'm going to come back up here because they told us f of 1 is 0. So now I can actually plug that in to find out what c is. So f of 1 is going to be 2/5, 1 to the 5th, plus 5/2, 1 squared, plus 1 plus c, and they said it equals, let me go back up there again, equals 0. Okay, so when I go through and put all that in there, so this comes out to be 2/5 plus 5/2 plus 1 plus c equals 0. I combine them all, move them to the other side. I get c to be negative 39 over 10. Okay, so my actual f of x function is going to be 2/5 x to the 5th plus 5/2 x squared plus x minus 39 over 10. So I think that's enough for this one video, and I'll continue on with the evens with another video.